The energy change needed for a change in state of a substance depends on the mass and specific latent heat of the substance. So remember that the specific latent heat of a substance is the energy required to change the state of 1 kilogram of it without a change in temperature. So the thermal energy needed for change is equal to mass multiplied by specific latent heat. In symbol form, that is E equals m times L. And this is one of the equations that's given on your formula sheet. The energy is measured in joules, the mass is measured in kilograms, and then the specific latent heat is measured in joules per kilogram. And that's because specific latent heat is simply energy divided by mass. Let's have a look at an example using this equation. Heat is supplied to 5 kilograms of water in a beaker at its boiling point. After 2.7 megajoules of heat has been supplied, there is 3.8 kilograms of water remaining in the beaker. Using this information, calculate the specific heat of vaporization of water. So for the first step, let's list all key information and check the units. The mass before is given to be 5 kilograms, and the mass after is given to be 3.8 kilograms. The thermal energy is given to be 2.7 megajoules. Now we need to convert this to match the units in the equation. So that is 2,700,000 joules. And we want to calculate the specific latent heat. So it's quite common in a question for you to have to figure out the change in a variable yourself. So in the next step, we want to use the starting mass and the final mass to determine the mass of water that was boiled. So we have 5 kilograms minus 3.8 kilograms, which gives us 1.2 kilograms. Now we need the change in mass rather than the given masses, as the change in mass gives us the amount of water that was actually boiled. So for step 3, we need to rearrange the specific latent capacity equation to make specific latent heat the subject. So we can do that by dividing both sides of the equation by mass. That becomes specific latent heat is equal to the thermal energy divided by the mass. Then for the final step, we want to substitute the values into the equation to calculate the specific latent heat. So the latent heat is equal to 2,700,000 joules divided by 1.2 kilograms. That is 2,250,000 joules per kilogram. And we can also give the answer as 2.25 megajoules per kilogram, or 2.25 times 10 to the 6 joules per kilogram.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!